Hi, this is Laura Chappell again, and I am here with Ginny Spicer.
Hello, and welcome to the LTP Wireshark Challenge.
Ginny is going to be taking you through a set of questions and explaining what trace file those questions go with. She is going to list the questions down for this challenge, and then we're going to recommend that you pause the video, go through the challenge, get your answers, write them down. And then once you restart the video, Ginny will go through the answers and how she got those answers. So Ginny, take it away. Why don't you show them the challenge questions?
Well, first, we got to start off with the trace file. It is LTP red large loss 2, and boy, does it earn that name. We've got lots of sessions, we've got lots of packet loss, we've got lots of retransmissions. Really want to stress the one hint you get, force the LTP dissector. You probably don't want to go through this one byte by byte.
Now, if they're using our profile that we made, they might find that the dissector's been forced for them, but they'll need to check that. If they don't see LTP protocol or LTP in that protocol column, they should know force that dissector. So go ahead, Ginny, give them the questions.
All right. And our questions are: 1. How many LTP sessions are in this trace file? 2. Which report is frame 4877 acknowledging? 3. How many bytes are being acknowledged by the report segment in frame 4854? 4. What is frame 1619's claim count? And 5. True or false? More claim counts in a report segment mean that more data is being acknowledged. And now
would be a time for people to pause and start up Wireshark and open up that trace file and try to answer these 5 questions.
Come back once you've given it a shot.
All right, now, Ginny, do you think they're actually pausing it?
I really hope so.
You know, a lot of times people just don't do it. They don't pause.
That's so messed up.
I know. I think it's cheating.
Yeah, probably.
That's my feeling. And we would know if people did that, right?
Yeah.
All right. Well, let's assume that they aren't cheating and that they did pause. And they went through the trace file and they got these answers. Why don't you go through and show them how you got the answers?
All right. First up, how many LTP sessions are in this trace file? Let's head over to Wireshark. All right. We have the LTP analysis Chappell Spicer profile active. So that is going to be part of how I find my answer to this. I am going to look at session numbers. It's really important to remember that your sessions are not the same as your streams. Going by session number, I'm going to filter, or rather sort on that column. And I can see that the lowest number is 2. It doesn't start at 0. If it was streams, it would. But then I can go to the end of the trace file, and I see 5. I'm going to go through and make sure, just in case, that 3 and 4 are there as well. I see 4. I see 3. With 2, 3, 4, and 5, I can say that there are 4 sessions in this trace file. Next up, which report is frame 4877 acknowledging? Let's head back to Wireshark.
I don't know that. Did you hear my Alexa go off while you did that, Ginny?
That was really spooky.
She said she doesn't know that, by the way, because she didn't take any training classes.
She probably didn't pause the video and try.
Now, Ginny, would you mind at this point making it so that we can see your info column?
Yes.
Because I know you have an ultra-wide monitor. And
I definitely have it set up for my ultra-wide, so I can scroll across to see things on this one. But just for the sake of this, I don't really need the time column. So I'm going to right-click, get rid of time. Don't need source or destination either. We can kind of tell that with the port numbers. All right. So now we can see our red data. And we are looking at frame 4877. So let's sort by numbers again if we aren't already. Yep.
Actually, Ginny, why don't you show them how to use that jump to button? A lot of people don't use that. So a lot of people are familiar with the arrows up on top, but there's one arrow where it's like it's pointing to a list, not the up or down, but yeah, show them that one where they could, when you do that, it's hard to see, but a little tiny menu area pops up and you can type in the packet number there to go to it.
4877. Did I type that correctly? Oh, no, it just jumped weirdly. Okay.
No, there it is. It's 4877. So
yeah, I think I was looking at ports because I was used to it.
The highlight bar doesn't really bring up stuff that well. So this is a trick that Ginny and I have where we right mouse click and we mark a packet to kind of call to really be able to focus on that packet when we're working with a specific packet. It just helps a lot.
This stands out a lot more. Okay, so to find which packet this report acknowledgement is acknowledging, since it's a report acknowledgement, I know it's going to be a report. So let's look at the report serial number. We've got 12826. I'm going to just sort by report serial number and look for another 12826. Sure enough, we've got one right here, and that is frame number 4874. We have found our second answer. Next up, how many bytes are being acknowledged by the report in segment 4854? The segment in frame 4854 even. Okay, let's sort by number again and head to 4854. So this report, as you can tell over here, has more than one offset in its claims. If we scroll down, we can see that it has 3 declarations. Since this is declaring some gaps, we really only need to look at the lengths and add them up. And for that, I'm going to use a very handy tool, my phone calculator.
Yes.
All right, length 1, 431612.
I'll read out the lengths. So add 431612 plus length number 1 is 139107 plus length number 2 is 24968.
All right. It is acknowledging 595,687 bytes. No? Did I type it in wrong?
Could have been. You want to do that math again? I'm going to read it to you one more time.
Okay.
Can you toggle back to the packet for me? Thank you.
Let me make sure I'm looking at the right one. It's 4854. Yes?
4854, yeah.
And that's all the claims? Sure is.
Okay.
Okay.
So, you're going to add 431612
431612
plus 139107
139107
plus 24968.
24968. I'm still getting 595,687.
That's the correct number. So you got to go back, if you don't mind, Ginny, for the people that are watching this, can you go back to the slide and manually edit that value?
Yep. So we now have 3 of our answers. Next, what is frame 1619's claim count? So I am sorting by that, and I'm going to go to 1619. Go to packet. And we can see again that there are quite a few claim counts. And I would really recommend that you not expand this column. You could, and you could count the number of items here, but we also have a claim count field. Rather than counting all 20 claim counts, we can look here and we have our answer.
Yeah, and there's actually a claim count field in the LTP header. If you want to show them down below, there really is a field that says that. This is not a Wireshark interpretation. This isn't Wireshark counting those up for you. It's actually built into the header structure.
Yep. So we have our fourth answer, which is 20. And the true or false. More claim counts in a report segment means that more data is being acknowledged. This is false. It seems a bit odd because you would think if it's acknowledging more things, that means more data. But really, more claim counts means that there are more chunks of data. Ideally, I want one big chunk of data showing that my transfer went smoothly. If you have a high claim count, it means that there's a high amount of little pieces missing along the way.
And if you take them back to Wireshark for a second, Ginny, I believe you could show them that, do we have where's our length? Can you bring up that column for length, or can you show them how to make a length column for, for the reception claims? Because not all of these are really big. In fact, I think at one point we found some length values that were like 1 byte.
All right. Wireshark has chosen to take away my...
I know that's really, really ugly. But, you know, you can see that they're varying lengths. So if a receiver wants to say, hey, I got these 2 bytes, the length, the offset will be there, and then the length will be 2. So it doesn't have anything to do with more data or anything like that. Each one of these offset and length groupings are created every time, you know, you basically have a gap in data that arrived. So you really have, I guess, could we say, Ginny, is it fair to say, the more reception claims you have, the more data loss points, not data loss. We don't know how much data was lost,
but points of data loss. Yes.
Yeah, I think that's a little bit more accurate on that one. Yeah.
That is the LTP Wireshark challenge. I hope that you paused the video and tried it and that you enjoyed it.
And if you didn't get the right answers, go back to the training session on LTP. In that training session, we provided you with the RFC and the CCSDS document information so that you can research LTP a little bit more. It's a bit of a different beast than what we're used to. And of course, we have the issue where the Wireshark dissector doesn't work in a couple of places, as we mentioned in the video where Ginny described the profile that we created.
Yep, that would be helpful too if you want to retry it, to check out the profile creation process.
Great. All right. Well, cheers, Ginny. It's time for you to head to the pub.
Cheers. Yep. Bye.
Bye.